Remember, we want to come up with the summation notation. So summation notation looks like this. Sum I equals 1 to n perhaps of a sub I. And the real trick, the whole ball game, is finding what I'm calling the ith term formula, a sub I. And then the other stuff is just putting the sigma notation in there. So what you really do is you look at the terms of the series are a sequence, right? Without, in other words, you delete the plus signs, you get the sequence 4, 7, 10, 13, and so on, right? And you want to come up with a formula, you'll make your input I instead of n, that generates these numbers. You want to see a trick? This will work every time for this particular kind of formula. What's the common difference? Remember earlier we found the common difference between successive terms and we came up with a formula involving n squared plus 1, I think it was. That trick of looking at the common difference, really, you're looking at the sequence in a recursive fashion, but that trick will guide you to the explicit formula. What is the common difference here? It's the same. It's 3. All the way, it's 3. So, I mean, that's a recursive definition. If I wanted to get the next term, I could add 3 and get the 16, right? If I want to get the next term, I could add 3 to the 16 and get 19. But that's recursive. We want an explicit formula. We have to have it for sigma notation. Well, here's the trick. What do you associate with repeated addition of 3? What operation is associated with repeated addition? Multiplication, right? So whenever you see that repeated addition of 3, the terms are going to be some variation of 3n. 3n won't work here because, you check it with plugging in 1. If you plug in 1 to get a1, you get into 3n, you get 3 times 1, 3. You don't get 4. What would you have to do to make 4 come out? Add 1. And it'll work every time. So you could check it. If you plug in 2, 3 times 2 plus 1 is 7. Plug in 3, 3 times 3 plus 1 is 10. It'll work every time. There's your, I used n out of habit. There's that habit again. But we're going to change it to I here. And we're not done, but that's the hard part. So that trick, by the way, works every time you have a common difference. You're going to take that, in this case it was 3, but whatever it is, and multiply it times the input, and then adjust it by adding or subtracting some number. And it'll work on these types of problems. It turns out if you think of it, this is a linear equation, that 3 is the slope. If you connected the dots. I mean, if you graph these, you wouldn't have you'd have dots instead of a line because you're only allowed to input natural numbers. But if you connected them and found the slope between the dots, you'd get a slope of 3. I'll say more about that later on. So anyway, if we fill in this, what do we get? The sum I equals 1 n 3i plus 1. You can put parentheses around it if you want.